Hello everyone. In this video we are going to work on an assembly problem that is used for CATIA Certification Sample Exam or Practice Exam. Okay, so in this problem you're going to put some parts together, three specific parts: the green part called long pin, the blue part called short pin, and then this yellow part called chain link. So a sample of each one is given to you in a folder that you can download from the CATIA Certification Exam software, and you can unzip the folder and use these components for assembly. You don't need to make them from scratch. So there are three problems, three angles here, A, B, and C, that are given as parameters, and they're going to change from, let's say, problem 3 to 4 and so on. And these three values for problem 3 are 25, 125, and 130 degrees. What you need to do is to put the assembly like this together and then find the location of the centroid for the entire assembly to see which one of these options it matches. The units are again in MMGS system. You need 2 decimals, and you need to make sure the origin with respect to which everything is measured, XYZ, is at the top of the long pin in the center, and this is the direction for X, Y, and Z axes. If it's anything other than this, then these numbers would be different. So you need to make sure that the origin of the CATIA system is right there. If it is, you're good. If it's not, then you have to create a secondary axis and measure everything with respect to that. And I talked about creating a secondary axis in one of the videos. So let's go ahead and bring these components and put them together. So here we go to CATIA Mechanical Design Assembly. And then here we click on Insert Existing Components, click on Product, and bring the long pin. And if you bring the long pin, you see that the XYZ is already set up the way you want, okay? And the Y-axis, X-axis, and Z is upward, so it's exactly matching this. And to make sure when you do a measurement, you got everything properly measured with respect to this coordinate, I go ahead and click on Measuring Inertia to see if it gives me the centroid. Okay, so first make sure your measure inertia is here. I don't see it right now, so I go ahead to customize toolbars and restore position. And now if I click on this guy here and click on this member, you see that the location of the centroid is X and Y 0, which is exactly in the middle, and Z is negative 50, which is the midpoint, because the length of this guy is 100 mil. Okay, the length of this cylinder is 100 mil. You can measure it here, right? Which is between this top surface and the bottom surface. Clearly you see the length is 100 mil, so negative 50 is measured with respect to the top point, so it is perfectly fine. You don't need a secondary system. You need one more of this, so what you can do is click on this guy and bring in a few more. Now here I assume that I used a few more pins, so I can delete the ones I don't want, or maybe I'll do it one more time so you can see here. So there are two options for creating replicas. This is the one that gives you 1. This is the one that gives you any arbitrary number of replicates. So here I just click on this, click on that, and for some reason, I guess it is under this guy that the setting is set to, yes, 3 instances. So you have to make sure this is only 1 instance, okay? So here I just make it like 1, and now if I do it on something else, it should give me 1 of that, okay? So you need to make sure the setting is right. And now if I click, you see it only gives me 1. Oh, 2, not 1 actually, and I wanted a line y-axis. Let's see. Component to instantiate is this guy. 1 extra, good. So that's 2 long pins. Then you bring in the short pin, you need 3 of that. So here we go. That's the short pin. And you see it's on the top of one of the previous components. So I go ahead and bring the manipulation toolbar and I move it. So I click on here and say with respect to constraint, always turn that on and get one of these guys off. Okay, and I need to move the blue component. Or what I can do is temporarily hide this, move this guy out of the way, and then bring it back. And remember, this is the first one we brought, and that point is 0, 0, 0. So the first thing I do is, maybe even before bringing any of these, fix this component so that it doesn't move and that point stays at 0, 0, 0. Okay, so I go ahead and apply a fixed constraint to it, and this way it should not move anymore. And then you can update it if you want. You can do a Control U, which is this guy is already updated, so I don't need to do much about it. And make sure you save your stuff. Don't wait until the end of the problem. Otherwise, if it crashes, you're gonna lose everything. Okay, and now I want 2 of this. So I click on this component for me to instantiate this guy. No, not the X's, of course. This one I want to create along y-axis. 2 of that, that's good. And then I need the chain link, so I bring that, and I need 4 of that one. Okay, and there's this guy, and now I move this out of the way. Now I go ahead and say I want 3 more of that, align whatever axis, doesn't matter. There we go. Save. So now I got myself the things that I wanted. Okay. And I'm ready to start the assembly. Now, for the assembly, if you look here, the first chain link hole is concentric with the shaft, and this surface of it is flush, is coincident with the top surface of the long pin. So that's the first thing you do. Also, the symmetry plane of this chain link has Z and Y axis on it, so it is coincident, the symmetry plane of that, with the ZY plane. Okay, so we need 3 constraints to fix its position and orientation. So we go here on the coincidence, and we'll make sure that the top surface of this pin and the surface of this guy are coincident with the same direction of the normal axis, and I update it. So now you clearly see they are coincident. Now in CATIA there is no concentric, but you can make the axes of the holes and the hole and the shaft coincident to make it concentric. So you click here, you go here, choose this axis and then this axis. And now since the axes are concentric, it means coincident, it means those 2 guys are concentric. So right now the position is perfectly fixed. but still it can rotate, right? If I say I rotate about z-axis, I can clearly rotate this. So now I need to go ahead and make sure that the zy plane of the original pin is coincident with the symmetry plane of this. So this member is this chain link, and it has three planes, correct? It has its own xy plane, yz plane, and zy plane. And I can see them if I want. So like exactly, you see zx is, as you can see here, zx is the symmetry plane, right? So that's the zx plane, and you can see it. And now if I say this zx plane is coincident with what? So I choose that and I say coincident with the line pin YZ plane, which is this guy. Set them to be the same, and now if you try to rotate it, it should not rotate, and you see it doesn't. Good. So that is what you have to do to fix the first component. Then you bring a short pin and pass it through this hole and make it flush, and then bring another chain link. By the way, we need three parameters A, B, C, and we have to create them. Let's create them now. So we click on this guy and say new parameter of type angle. Give me 1, and then instead of angle 1, I call it A, and make sure the amount is correct. So that's the first one. We need B of 125 and C of 130. So give me another one, call it B, and the amount is 125. Give me another one. This guy is called C, and the value for it is 130. Okay, so now I got those, and then I can use them. So let's go ahead and grab one of these pins and pass it through this hole. So here we go. First it is concentric, then it is flush with here. And so there we go, it is in. Now the second chain link is fit to the pin and short pin and the first chain link with the angle between these two surfaces to be equal to A. Okay, so we have to fix the position, and then the angle should go through angle A. So this is what we do. We make sure first the axis of this pin is coincident with the axis of this hole. Okay, and then we make sure that this face and this one will sit on the top of each other. There we go. So now it is where it should be, and now I can rotate it about the x-axis and put it at any angle that I want. Now the angle I want is equal to A. So what I need is to create an angle constraint and create it between this one and this one. And then instead of this, see if we can say this is equal to something, okay? Whether we can say this guy is equal to A. So we say parameters of type angle, then we choose A for it. Now for some reason it does not show it right. I am not happy about it. It has to say equal to A. There we go. Good. So now it's exactly 25 degrees. Save. Now we go with the next short pin. Here we go. And Here we go. Okay. So now I got the second pin done. And now I need to go with the next chain link, which again has the same connection with this pin, right? The pin passes through the hole and it has the flush constraint with the surface of the previous chain link, but now it is rotating about the axis of this pin with angle B, okay? So let's do it. This one and so what we need is this one and then the axis of that. Good. And we need this surface to be coincident with this one. There we go. Alright, and now I should be able to rotate it. Now pay attention that the axis of this pin is not any of the X, Y, or Z axis. So if you choose rotation about X, Y, or Z, you cannot rotate this because the axis of that pin is not X, not Y, not Z. So you have to choose arbitrary axis and then choose this axis as the axis of rotation if it allows. And now you're able to freely rotate it about that axis. Now I go ahead and create the angle constraint, which is between these surfaces, this one and this one. And if you look now, the way the angle is defined is in the first sector, so it is 180 minus B instead. And if I say second one, actually it should be fourth one or third one, the way it is. You see, it says 130 something. So instead of this number, I right click, say edit formula, and say this is equal to B, which is 125. And I set that up. And now my third member is good. Let's go ahead and apply the next pin. There we go. Now the last chain link, again, it goes through that pin and it is now rotated about the axis of that for angle C. And so we have to get the axis of this guy. There we go. So here's this one, here's this one, there we go. Then we have this face and this one. Set. Good. Now the angle of this should be C and it should be upward. So first let's manipulate it. By the way, let me get this guy out of the way. So now I say rotation about arbitrary axis. Has to go. There we go. Bring it up. Perfect. Now apply it. This one and this one. The sector is again wrong. Go with the third sector and change this to angle C. Update that. There we go. All good. Finally, you have to make this pin flush with that surface and coincident. So let's go ahead and do that. And I can do a zoom onto that area. There we go. So now it looks just like this, as you can see. And now it says find the location of the centroid. Make sure the unit is mmgs and tell me where the centroid is. So I make sure under tools options that the units are mmgs. So we go under parameters, measurements, units, And you see this millimeter, S, and G, so it is good. So here we go, we click on measure inertia, click on the product, and it gives us the location of the centroid with 2 decimals, negative 20, 643, 105.31, negative 2526 is the location of the centroid. And if you look at here, that's the same as the first option. Okay, so that's the answer, and you see that's the right answer here as well. Now it says change the angles to 30, 115, and 135, and measure the centroid location one more time, okay, and tell us how much. So here we go and change those parameters. So we go here, and you see that's 25, it says change it to 30, so double click on it and change the value of that. That should be 115. The next one should be 135. Update it and measure it again. The numbers are negative 2984, 99, and negative 2825. And if you look here again, you see that these are these answers for question number 4. Okay, by the way, here there are 2 first problems that are really from drafting, and these are the same problems as we had in the part design, right? So you have a clipping view here and you have a breakout view here. So if you see some sample questions in the assembly exam, don't be surprised. In an assembly, in the beginning of it, you might get a couple of multiple choice on drafting as well, okay? But the overall assembly thing is something like this. You're given some parameters, angles, distances, whatever, and you're supposed to put an assembly together where the components are given to you. You just assemble it, use some parameters, and do some measurements and report it or compare it against some answers, okay? So the assembly is not going to be really a very difficult exam. Okay, so I stop this video here, and in another video we'll talk about surface design sample exam for CATIA certification, and I'll see you there. Thank you for your attention.